Hello, and welcome to the second part of C programming with C99. There are a few things in order which I would like to tell you first, which I perhaps forgot in my last part. Why I say this is C programming with C99? Because C99 is the latest specification supported by all the compilers. C11 was released last year and still not fully supported by all the compilers. Specification is given by ISO committee. Earlier it used to be MCC. Lots of code is available in MCC, and C99 is fully compatible with MCC. So in our last part I had promised that I'll dissect this program, the sample template program given by Eclipse. Before that, let me advertise my website. This is my website, libreprogramming.org. Here you can find a book on C programming which covers the basics and is more like a treatment of specification. Not very detailed, but it has sufficient detail for beginners. It's a big one. There are certain rough sections, like I intend to give examples for all the functions available in libraries, and there are 2 chapters which I will add. Those are on strings and file IO, and some complementary things will be given in this book. It is not yet complete, but you can still read it because it's fairly complete, 90% complete. I'm also writing my second book, which is on programming in data structures. It has just started, so perhaps you would like to wait. There are some videos, including the previous one. You would like to go through fixed, and perhaps if you have not installed Linux earlier, you would like to go through how to record GNU Linux Mint. This is on VirtualBox, so you can see the video actually to how to really install Linux as is to Kubuntu. And then if you have got questions, you can come to my website qa.libreprogramming.org and you can ask programming related questions. You can also ask mathematics, physics or chemistry related problems, as I can answer them. Other than educational questions, other questions are not allowed. Do not try to post your backlinks. Do not try to do that. I will immediately ban you, because I'll show you this user which you see. Okay, I think I have deleted that user, or I need to log in to show you. So if you come to my website and you try to produce spam, and you see this user, I have banned him. Your IP will be banned forever. No spamming is tolerated at all. People are friendly here. It's a new website and just for my students. So perhaps if you like, you can ask your questions here. If you want to read, you can read. If you do not want, just watch videos. That's also cool. So let's go back to our program. Before we deal with this program, I would like to show you how to compile from command line. Okay. So this file is in our workspace. Hello. So Eclipse puts file in 3 directories. One is your src, another is your debug, and one more is release. Release and debug directories will keep the build files, while src will keep your source code. So we have hello.c here. Eclipse will automatically compile your file based on your compiler settings. However, there are certain flags which I use while compiling. Perhaps you would like to know them. Since we are using C99 features, compilers require a special flag. -std is equal to C99. I like to get all the warnings from compilers, so I say -w all, and I treat all warnings as errors, -w error. Then I put one flag, pedantic, and then you type hello.c. So you get a.out. And if you want to put it in another file, hello, so you got your hello. So Eclipse will put these files in debug directory, so that's where you should look, and Eclipse will name it hello or based on your project name. Okay, so let's come back to our program. This is a very small program, but it has many features which you can actually look into. First part is these comments, which I have told you in my last program. Anything between /* and * is commented. That is, they will not be taken into code. They are simply ignored. Second is one line comment, 2 forward slashes. It comments out one line. There is one gotcha though. If you comment like this, so if you think that this /* and this * will comment out this, that's not going to happen, because the compiler parser is greedy in nature. So this will be matched with this, and this will produce you syntax errors. So be careful with this. Single line comments, it will comment anything in the single line. So if you put */ or / anything in that line, it won't affect. So this is your template generated by Eclipse actually. So it gives a name, it gives your copyright notice and description. If you want to put a version, you can put a version, author, whatever. So first line is #include stdir.h. #include is a preprocessor directive, and stdir.h is standard input-output header file. This header is provided by compiler and is specified by C99 specification. If you want to take a look, you can have a look. You right click and say open declaration, or you can simply place your cursor here and press F3. It will open the stdir.h. You see, it clearly mentions ISO C99 standard, and I have got the latest compiler. It still does not have C11 standard. If you want, you can browse through this, but please do not change this file. Okay, so it just includes the header. What a header contains is it contains declarations and function prototypes, macros, etc. You'll learn a lot more about this later. For example, you see you've got some macros here. It includes some other headers. So there are lots of macros in the beginning, or anything which begins with a hash is a macro. And then you have got declarations, lots of declarations. Etc. You will see many functions, flush unlocked. Some description is there. So if you want, you can browse through, and we'll come back to this. Next is int main. Int main is a function prescribed by C99 standard, which is supposed to be the starting point of every program. Every program must have one main. Any program which does not have a main function is not standard compliant program. It must have main. There are two variations of main. One is without arguments and one is with arguments. When you say void or you leave this empty, it's without arguments. Second version prescribed by SOC is int argc, or whatever you name the variable. It's a variable of integer type. Don't worry about types as of now. And the second one is argv. So this is actually the argument count which is applied by command line, and this is the argument value of the strings separated by space. This is typically a pointer to pointer. It is also written in this fashion, array of pointers, but I prefer to write it this way. We'll see the difference between these two later. And the curly braces are beginning and end of the function. A program is composed of several functions. C program, it's composed of many things, but as of now it is composed of a function, main. You can have other functions, anything you want. Next is a putS function provided by standard IO library, which prints string and then prints a new line. You can see its description here. If you mouse over your mouse or this function, then you will see the description. You can also look up this description in man pages. You type man putS. This description is much more authentic in my opinion, because it is written by compiler authors themselves. So, and all the man pages are, I think, in the third section of man pages. Man pages have got 7 sections. You should refer to third section, because if you say man printf, you'll see this. But if you say man 3 printf, you'll see this. So third section is your standard library section and is called Linux Programmer's Manual. Okay, it may be called Solaris Programmer's Manual or HPS Programmer's Manual, it doesn't matter. Okay, so this is the function. So it is supposed to print our string. Also note that the arguments of a string, this is a function call, note down, this is a function signature, this is the body of the function. Now this function, when you call, you have got parenthesis. Anytime you encounter a function, you have got parenthesis, and strings are in double quotes. So we have got double quotes, and then we have a comment, what it does. And last line is return 0. When you have this, which is an integer, a function which has got this before its signature, then it should return that value. It's an integer, so it should return an integer. SOC C99 prescribes that it must return an integer. It must. There is no optional constraint here. It's a mandatory requirement that you return an integer. So typically people return 0 to signify that the program is successful. Non-zeros values are error problems. For example, if you want to see, then you will see the return values at the end. Okay. Okay. So you see this. It will return -1 in glibc 2.0.6. Typically it returns the number of characters printed, function printf, but it may return non-zero values if it fails to do so. It's a convention actually that if you return 0, your program is successful, but if you return non-zero, then that particular code, the particular value which you return signifies that this is what the problem is with the program. For example, say I want to open a file and the file does not open because it does not exist, then I may return error code 1. If the file exists but I cannot open it because I do not have read permissions, then I can set error code 2. I can say return 2. So these are two different cases which I can document in documentation of my program. Then a person who is using my program, if he sees the code 1, then he will know that, okay, the program has returned 1, that means the file does not exist. And if it is 2, that means there is some problem with permissions of the file. So accordingly you can manipulate your settings or change your environment or do whatever is needed to run the program successfully, so that it helps, to have properly documented error codes. Okay. Now you will ask, how do we know that 0 has been returned? So I'll show you. Let's build this. Last tutorial I told you that it automatically builds, so simply run it. So it will build it and run it. Okay. You cannot see the return value here, right? Alright. We go to debug directory. I got the file hello, so I run it. Tool. On your command prompt you type $echo $. You see that 0, right? Okie dokie. Now I set it to 1. Okay. It built. See? Okay. Okay, we did not run it. 1. Okay, if you are not still convinced, close it. 100. Think now you are convinced. $? Is a shell variable which prints the value returned by the previous execution of program, and if you do this again you get 0 because echo returns 0. This echo returns 0 here, so we got 0 over here. You see the point, right? Okay, so that was pretty simple. Some basics about Eclipse. Eclipse supports many build tools. It supports auto tools out of box. It can be used to support CMake, their plugins. I'm not very sure. There are open source plugins. There used to be. I have never used any CMake plugin, but someday I'll show you how to use CMake with Eclipse. I suggest you learn 3 build systems if you want to make your career in Linux programming, and those 3 are auto tools, which comprise of autoconf, automake, and libtool, and CMake, which is another popular build tool, very powerful, and sconf, which is written in Python. So you will need to learn Python a bit. CMake has its own language, auto tools have its own language. Auto tools use M4, which is a common denominator of shell scripting languages. Typically bash shells are used in Linux. Sometimes you will find that the configure scripts generated by auto tools do not work on other operating systems because it expects the default shell to be bash. Sometimes something happens and there are errors. So I recommend you to use bash shell if you want to use configure scripts. Auto tools basically do many things. It generates a configure script which checks your environment, what libraries are available, what programs are there, which compiler, GCC or CLang or some other compiler. If your program requires Python or headers or functions, it checks them. You can do plenty of things. There is another very useful tool called package config, which is used to get appropriate flags for compilation and linking. For example, if I say printf Okay, leave it for now. So you may be wondering what is library and all that, but let's forget that for now. We will deal with that later. Let's not put too much in that in here. CMake is another tool which is kind of auto tools, but it does not generate makefile like auto tools. It generates your platform specific files. It can generate makefiles also, but it can generate project files like Visual Studio project file, or maybe your Eclipse project file, and various other project files. Sconce is on Python. It does not create a makefile or nothing. You have got a construct script which outright builds your program. You should learn auto tools, in my opinion, and CMake. Many open source projects have started using CMake, but I am a fan of both auto tools and CMake. Okay, some things which I should show you. The preferences of Eclipse which we will be using are here. Right click on project properties. This is your most useful location where you can change things. You can change compiler flags here. So if you want, you can say std is equal to C99. You see, there is no W error here. This is the debug flag, zero optimization. If you want to see all the flags of GCC, you can see here, man GCC, lots of them. It's a big man file, so perhaps you would like to read it. It has got 11,000 lines in its man page. Happy reading of GCC man page. I never read it, I just read when I need it. Honestly, I don't know all of it. So you can change your settings here. As I shown, you can change several things here. We'll be changing some of these in our programs. Run debug settings here, and you can change many things here. Code analysis, launching, documentation, file types, formatter. There are many styles actually. If you want, you can use any of these. You can have a look. Whichever you like, you can use that. I think we have dissected the program, and I showed you in my last part how to set the two very important parameters, and I hope you have not forgotten them. Okay, one is this one, build on the source wave and enable parallel build. Okay, so that's it for now. In my next part we will proceed with several things. However, I will recommend you some books. Of course, you can read my book, but there are some very good books if you want. First is the book by Cunningham Ritchie, The C Programming Language, which is kind of the holiest book in programming. So you will definitely like to get a hand on it, but it is not for beginners, I must say. I mean, when I was a beginner, I found it difficult to read through Cunningham Ritchie. Another book is a very good book. It's called Programming with C by Byron F. Gottfried. Okay, let me write it here. Programming with C by Byron F. Gottfried. Good book for beginners. Not fired. Bad. Okay. So, pretty good book for beginners. Just one problem, it uses archaic Turbo C compiler, so you may have some headaches there. Another book is The Spirit of C by Mulch Cooper, if I remember. Mulch Cooper. After reading one of these, and perhaps my book, I'll say it again and again, read my book. And then one more is Expert C Programming, Deep Secrets by Peter van der Linden. I think I got spelling right. Another book is C Traps and Pitfalls by Andrew Connick. And you should always read the specification. You can Google specification, C99 specification. I use one particular version which is named 1224.pdf. It's a draft, but I cannot afford to pay $300 for specification. I'm a poor guy, So you can read these four. I would recommend going through Gottfried and Mulch Cooper first, and then you can proceed to these two. Okay, not pitfalls. And if you want any help, you can always ask me questions at my QA, and also you can read my book. And please point the spelling errors and grammatical errors. English is not my native language, so if you got anything to report, please report it. And I won't pay you 255 cents as Donald Knuth pays for one error in his book. That's it for now. I said it twice, right? But I still have got something to say. There are 5 stages. There are several stages, not 5, in compilation. One is preprocessing. It preprocesses the file. There are several things which happens when you preprocess. One is your line continuation character is removed and lines are joined. We'll see what is line continuation character. Then second is that your trigraph sequences are replaced. Perhaps you will never use trigraph sequences in your entire life, but just to let you know that all multi-byte characters are mapped, and all macros are replaced. So you see hash include stdr.h, so the whole of stdr.h and included headers in stdr.h all are taken. And if you want to see, I'll show you. Okay. Not flash. .c. You see, all the headers are included here. It will become a big one. Lots of files are included here. Okay. That is the first stage in compilation. Now the second stage is the compilation of the file itself. This you can achieve separately by gcc -c. Before this stage, preprocessing will happen. It will produce a .o file. This is your object code. You can know about type of file by typing file space hello.o. So you see, it says 64-bit LSB relocatable, because my system is 64-bit. And then the final stage is the linking. Typically you do not invoke linker LD manually, because GCC invokes linker internally, and it's easier to link using GCC. So these are 3 major steps. There are other stages like assembling and optimization stages, which GCC can internally invoke. If you want to see the assembly code, you can see it. Let's see. So you'll see hello.s file, which looks like this. This is your assembly code. So don't ask me what is this. We are not reading about assembly programming at the moment, just to let you know what goes on inside. Okay. And if you want to know what type your executable is, so you can know here. It is a dynamically linked file, executable 64-bit. We'll read about this. What is shared library for what Linux? This is some build ID, SHA, checksum. It is not stripped. If you want to strip, we'll deal about stripping later, not now. Okay. I think final time I'll say that's it. See you in the next part when we'll learn more about all this programming stuff and see. Happy coding. Thanks. Enjoy.